Yeah, we're gonna do chapter 8. We'll do like a little. We'll do kind of like a short version since we took the corrections and we don't have quite a lot of time. But I'm gonna talk about this one thing, and it's called the geometric mean. All right. Now, when you think of mean, you think of in math terms anyway. There's a lot of you think of the average. Okay, this is not really an actual average. I'm not sure where the word comes from exactly, but we call what we're going to do right here, we call it the geometric mean. Now what I'm going to do is I'm just going to go through very, very quickly and just kind of give you a basic idea of how we came up with this thing, all right? And I think you guys can handle it. Some classes I wouldn't go through this stuff because I just think that they would get lost, but I think you guys can handle it. Look at this stuff right here. It's already prepared. I already did it earlier. And so what we have here, this is the situation when we use a geometric mean. All right, we use the geometric mean basically only under these circumstances, but you will have situations like this. So what we have is this. We have a big right triangle. Do you see that big right triangle right there? Okay. See, it's got a right angle. Everybody with me? And then you have an altitude drawn from that right angle. So you're going to draw an altitude from this right angle. An altitude means what? It starts at a vertex and it goes perpendicular to that side, the opposite side. Everybody got that? So this is the situation when we're going to use this thing called the geometric mean. I'm just going to show you very quickly, I hope, where it comes from. So let's do this. Let's label some of our sides. Let's label that A, B, C. I'll label this little one right here D, and this E. This D just goes from here to here. Everybody see that? And the E goes from this right angle all the way down to this end. All right with that? Now let's take a look at these. What I've done right here, what do you think this little blue one here is compared to this? What do you think? It's the same exact thing, right? I just took it apart, right? I just traced over it and I just slid it down here. Okay, so this triangle is exactly the same as this triangle right here. Everybody with me? So what I want to do is this. And we just finished a chapter where we talked about this stuff, so I want you to see something. Look at the whole big triangle. This whole big triangle, it's got a right angle in it, doesn't it? And this triangle's got a right angle in it, and so does this one right here. So in order for the triangles to be similar to each other, how many angles have to be equal? At the very least, what? 2. Right. If I get 2 angles of one triangle equaling 2 angles of another triangle, then the 2 triangles are what? They're similar, right? So let's see if we can get that. Look at this triangle right here. You have a right angle here, and I'm taking a look at this whole big triangle up here, right? Okay, and it has a right angle. So that's one angle they have in common. Do they have anything else in common? This one down here, right? Did you see that? They both share that angle. So what's true about this little blue triangle compared to this whole big old triangle? They're similar to each other. How do I know that? Because angle, angle, similarity. Remember that? Let's do the same thing with this triangle right here. This triangle also has a right angle, doesn't it? Because we drew an altitude. And the big triangle has a right angle. Does the big triangle and this medium-sized triangle have anything in common? Yeah, this angle out here. Do you agree? So this angle and this angle are equal to each other. So what's true about this blue triangle here and this whole big triangle up here? They're similar to each other as well. Do you agree? What's true about the 2 blue triangles? Look, this has 2 angles. Actually, I'm sorry. You can't say that. But you can do this by, I guess you could call it transitive property. You remember transitive property? If A equals B and B equals C, then what? Then A equals C, right? Okay. Jesselyn's right there. Jesselyn, no, can she just see me after class? Absolutely. Thank you, Jesselyn. Thank you. You're welcome. All right, Beverin, make sure you remember that, okay? So let's take a look at this. So watch. This, we'll call this the A triangle is equal to the B triangle, or not equal, but what? Similar. Okay, so the transitive property even works with similarity. So if the first triangle is similar to the second triangle, and the second triangle is similar to the third triangle, then guess what? The first is similar to the third. Would you agree? So all these are similar to each other. So if they're similar, we can set up some ratios. First of all, this side right here is what? It's taken from this big triangle, so this has to be the same exact side as this. Would you agree? That's A. What is this up and down one? That's C. What's this little one down here? That's D. Agreed? What about this one? What do we have here? That's C, that's B, and that's what? E. So let's set up some similarities. Let's take a look at this little triangle to the big triangle. All right, I did this earlier, so I want to remember if I could do this. Actually, let's do that. So I'm going to set up a ratio. Watch. I'm going to compare C to D. That's supposed to be a C. Kind of looks like an E. Let's make it look like a C. There we go. All right. Let's compare C to D. All right, because they are similar triangles, aren't they? All right. So let's compare this C to this D. So what is C? C is opposite. Let's see how I want to do this. Yeah. C to D. And then let's compare this triangle over here. So look at this. C is opposite. Now if this has one arc and this has a right angle, how many arcs should this one have? It should have 2. If this one has 2 and this is the right angle, what should this be? That's 1. Do you see it? Okay, here we go. Watch. If I compare C to D, C is opposite the 1 arc, D is opposite the 2 arcs. So let's look over here. What's opposite the 1 arc over here? E. And what's opposite the 2 arcs over here? C. So that would be one of our ratios, one of our proportions. Does that make sense? All right. And if you don't completely follow this, that's okay. What we're going to do is I just want to show you where this comes from. All right, so that's one ratio. That's actually a geometric mean. We'll talk about that in a second real quick here. All right, and let's do another one. Let's compare D. Let's compare D to, let's do this. I'm trying to, that's 2 arcs right there. So watch, let's compare D to the, no, I'm sorry. I don't want to do that. I want to compare A. I'm doing this in a certain way because I know what I want it to end up to be, all right? So let's compare A to, let's compare A to D, all right? Let's compare A to D. Now watch. A is opposite the right. D is opposite the 2. You follow me when I say the 2 arcs? So A is opposite the right. D is opposite the 2. Let's take a look at this big one right here. Which one is opposite the right angle on the big triangle? This whole thing, right? So it's not just D. It's not just DE. What is it? It's D. What's this whole thing from here to here? Plus E, right? It's D plus E. Do you see that? Because how did I make that comparison? A is opposite the right angle on this little triangle. What's opposite the right angle on the big triangle? D plus E, right? Well, look at D. D is opposite the angle with 2 arcs. Which angle up here is opposite the angle with 2 arcs? A. This is another geometric mean. And you're going to see a little bit of, I don't know, yeah, a little repetition, I guess. I'm thinking of another word. I can't think of it right now. But let's do another one. And I'm just trying to get myself some room here. We'll just slide it in here. What I'm going to do is I'm going to compare, on this triangle over here, I'm going to compare B to something. Let's compare B to E. Alright? Now watch. What is B opposite the right angle? What's opposite the right angle over here? D plus E. And E is opposite the 1 arc angle. What's opposite the 1 arc angle over here? B. Alright, there we go. That's what I want. That worked out pretty nice. I want you to see something here. In fact, let's just copy this. Get rid of that. Okay, let's just get rid of that. Is that alright? There we go. So let's put this up here like this. Alright, actually let's do this. Slide this over here, and we'll slide this stuff right in here. Let's go back and get that original triangle that we had. Alright, here we go. Now we're getting somewhere, don't worry. Alright, I know you're probably really confused. You're like, what in the world's he doing? Well, I'm glad you asked because I'm going to show you. What did we call this side? This was what? A, wasn't it? Remember that? Is that what we called it? Remind me, because I don't have it in front of me. What was this side? Was this B? And then this one was C, right? And this one was D, and this one was E. Agreed? All right. What we're going to do is, I've actually got 3 geometric means up here. Let me show you something real quick. Let's make this a different color. Let's just make it red. Make it this red. Yeah. And I'm showing you where we got them from. Look at this right here. You see how they're both the same letter? What's true over here? That's an A, and that's an A, isn't it? You see it? And look at this one. It's kind of unusual that we got that. It's kind of like a pattern, isn't it? Do you see it? Yeah, we did, but it works, though. It all works. So what I want you to see is this. I'm basically going to read off what the theorems basically say here, okay? Maybe not word for word, but in my own words, okay? So look at C. Do you see how these letters are the same color? They're both the same thing. We say that C is the geometric mean. So what does it mean to be a geometric mean? Well, it means this. It's a proportion. When I say, for instance, let's just use some general letter. Let's just say X. If I say X is a geometric mean, that means I'm going to put an X here, and I'm going to put an X here. Okay? So when I say X is the geometric mean, I'm going to put an X on opposite ends of my proportion. You got it? They could have gone over here like this if you wanted to, but I usually put it like this. And they're going to say X is a geometric mean between 2 numbers. I'm just going to make something up. Let's say 3 and 6. Okay? Let's not even use 6. Let's use just some 12. Yeah, that would be perfect, actually. Okay? So let's take a look at this. So what if I said, and they're going to have problems on the homework. They're going to say, find the geometric mean between these 2 numbers. And what does that mean? That means you set up a proportion. When it says find the geometric mean, you put them on opposite sides like this. Everybody with me so far? And then between these 2 numbers, where do you put the 2 numbers? In those 2 empty spots right there. Now, what's the math involved to solve for X? That's it. Yeah, exactly right. So X squared equals 3 times 12, which is 36. Take the square root, and X is what? 6. So if I asked you for the geometric mean between 3 and 12, you would tell me it's what? It's 6. Okay? Look at these. Don't these look like geometric means up here? They are, because look, these 2 are the same. That's the geometric mean. C is a geometric mean. These 2 are the same. That means A is a geometric mean. These 2 are the same. That means what? B is the geometric mean. But between what 2 numbers? Now, we're going to repeat this a lot, okay, as we go through these type of problems. C is the geometric mean. Well, watch this. This is your altitude of your whole big triangle, isn't it? C is the geometric mean between the 2 segments of the hypotenuse. Do you see the whole big hypotenuse right here? It's broken down into these 2 little parts, right? So C is the geometric mean between what? Between this and this. So for instance, what if I said that was 3 and that was 12? I could now solve for C, couldn't I? Because C is a geometric mean between the 2 segments of the hypotenuse. All right, so you would do what? I'd set up a ratio. I'd put C here, between what and what? Between 3 and 12. Does that make sense? All right. So, and then you could solve, and you could solve for C, right? You cross multiply, and you got what C is equal to. Look up here. Look at this. Let's do this in a different color. Look at A. A is the geometric mean between what and what? Well, between D and between D plus E. Well, let's see how we can say that. This side of my big right triangle is the geometric mean between the whole hypotenuse and the segment of the hypotenuse that's adjacent to that side. I'm going to say it again. Listen, you guys are talking, and you're not hearing what I'm saying. I'm being very specific with my words here, and I want you to listen to me. This side of the right triangle, this leg of the right triangle, is the geometric mean. What does that tell you? That means, oh, I put that here and I put it here, right? It's the geometric mean between what 2 sides? Between what 2 numbers? Between the whole hypotenuse and the segment of the hypotenuse that's adjacent to that leg. So the one that's next to it, right? So A is the geometric mean between the whole thing. If I use 3 and 12, what number would I put? 15, right? So A is the geometric mean between the whole thing, 15. So let's do that. A is the geometric mean between the whole thing, which is 15, and the segment that's closest to that A. Which one is it? It's the 3, isn't it? Because this is not the segment of the C is not the segment of this hypotenuse. This specifically says, and if you look up here, it works. Look, A is a geometric mean between what? Between D and the whole entire hypotenuse. Do you see that? And that tells you by your similar triangles that that would be true. Let's do one more. Well, it would be a square root. 15 times 3 is 45, square root of 45. And that's how you would write it. Yep, you would just take square root of 45. 9 times 5, square root of 9 is 3, 3 square root of 5. Can you do that in your head? Okay, let's do this. We're running out of time. We only got a minute left. So watch. Now look at this. B is the geometric mean. What do you think? Now A is a geometric mean between the whole hypotenuse and the segment that's next to it, right? What do you think B is? B is also a geometric mean between the whole hypotenuse, which is, what, 15, and the segment that's next to B, and that's 12. Okay, yeah, it's a big number, but that's how you set it up. Once you know how to set it up, then it's easy to do the math. Wouldn't you agree? Just cross multiply, you're going to square root, and then you just simplify it. Okay? And that's how you do geometric mean. And how did we know all that stuff was true? Because we came up with it up here, didn't we? All right? So that's what you're doing right there. Review the video. I know I went a little quick on the end. Now, look, right now, listen, right now, I'm not going to expect you to simplify this. Just get a big old number, stick it under a square root, okay? Tomorrow we'll work a little bit more on showing you how to simplify that. Oh, yeah, we got homework. But I'm just saying, you don't have to simplify this. For right now. You will eventually, but not today because we didn't have time to go over that. So, that was 8-1. So it's numbers 8 to 23. Okay, on section 8-1. Just look at section 8-1. You can figure it out. It's 535 and 536. There it is right there. So you're doing 8 to 23. Go back and review the video, okay? I know I went a little fast because we didn't have much time today. But if you watch the video again, it should make a little sense to you. That thing right there. Just follow that right there.